Hello, welcome to the New Stack Makers, a podcast where we talk about at-scale application development, deployment, and management. Hey, it's Alex Williams of the New Stack here at MesosCon in Los Angeles, California. It is coming to the close of the conference on a Friday afternoon, and I'm lucky to have some people here from Portworx and GE Digital. And so what I'd like to do is for you guys to introduce yourselves. Okay, why don't you introduce yourself first, and then we'll go around.
Sure. Hi, my name is Goutham Rou. I'm the CTO at Portworx.
Hi, my name is Balajee Nagarajan, Director of Software Engineering at GE and Predix.
Hey, my name is Venkat Sivasubramanian. I lead the data platform for Predix.
Great. The topic for today that I want to discuss is about storage in the maturing container technology ecosystem. We now have seen containers become widely used since their introduction really as Docker 3 years ago. And now we're seeing the need for companies to really think more about networking and storage. And Portworx has a particular focus on storage. And so perhaps you could tell us a little bit about Portworx and what you guys do.
Portworx builds cloud-native storage software. What that means is it's a new kind of storage solution designed for applications that are deployed via container orchestrators such as Kubernetes or DCOS. Modern applications are service-oriented. They're packaged as containers, and they're inherently meant to be run on cloud-native infrastructure in a distributed manner. Essentially, what is fueling all of this is the need for enterprises to embrace DevOps and agile software development and deployment methodologies. Where Portworx comes in is we provide a storage layer that is purpose-built for these kind of applications. The whole premise behind it is programmatic deployment or consumption of storage services for these applications like Cassandra, Postgres, Mongo, these type of applications that are packaged as Linux containers and deployed by a container orchestrator. These applications can programmatically specify the type of storage resources they want. They don't need to know what kind of physical underlying infrastructure they're running on. They don't need to know what kind of public cloud provider they're running on. Portworx provides that abstraction layer, something that the DevOps teams can directly deal with. It gives them a uniform experience, much like DCOS gives a uniform compute experience.
So how are you all working with Portworx? What's the connection between GE Digital and Portworx?
So before we go there, let me set the stage of what GE Digital is doing first on Predix. So Predix, we started on this journey of Predix a couple of years ago. Predix is a world-class, highly secure industrial IoT platform that GE is building back in San Ramon, California. What this gives us as GE, GE has been a forefront of in the industrial space for a long, long time. What we bring to the table is our industrial wealth of knowledge on how to, our domain expertise on GE verticals like aviation, power, transportation, oil and gas, lighting, all that stuff. What we're then doing next is take all of that expertise to digitize the industrial internet itself. So we're building the next gen industrial internet. As part of that journey, we have a world-class Predix platform as a service that we back in San Ramon are building.
That's right.
In that, we used today we use Cloud Foundry, and we're adding our stateful container architecture using Mesos. Portworx is our partner in crime, helping us to solve that stateful need in Predix.
Why did you choose Portworx? Why are you working with Portworx?
So when we started looking at Mesos, probably 6 to 8 months before now, so we started looking at Mesos particularly for the persistent store, the capability that it actually offers from an orchestration perspective. Because when Predix platform was originally started, we've always been with Cloud Foundry. There is a there is a big community within Cloud Foundry, and we have a large presence in Cloud Foundry. And Cloud Foundry has been good for stateless applications. Though when we started looking at Mesos, for us, one of the primary things is we looked at CSI, which is a container storage interface. That was actually available at that particular point. But it was still not ready, it was still not matured enough. So we started, okay, but we do need to do a single infrastructure. We need to have a single infrastructure that actually allows us to be able to run both stateless and stateful. And Portworx had a great solution with DVDI interfaces, and that was like ideal for us. And it also offers a few things that are actually super important from an industrial company perspective. One is security and compliance are like super key for us. So we need a solution that actually supports encryption out of the box from a storage perspective, snapshotting out of the box available. And so Portworx had those capabilities, which actually made us gravitate towards Portworx.
What are some of the challenges that you're seeing customers face with storage environments? We're seeing more capabilities to use adapters, for example, into different storage environments, right? These plug-in type services. What are those issues that you're seeing customers face when they start, exploring how they actually can run these applications that are in these stateful environments effectively using container technology?
One of the fundamental tenets of what Portworx is building is to actually provide that abstraction layer that sits on top of physical storage. The problem that people typically run into is when they try and take a traditional volume and try and somehow orchestrate that into a container. And let's talk about that a little bit. Traditional storage, like an iSCSI, these are meant to drive storage to a host computer, to an operating system, to a machine. They're not designed to provide storage resources to an application running inside of a container. In other words, almost any SAN or NAS solution out there, its end user or its client is typically a host computer, not a container that's been orchestrated by a container orchestrator that is meant to run in a multi-node environment. And let's double click on why I say that. An application is never one single container, right? So take an example of Cassandra. It's usually deployed as a set of containers. A Cassandra cluster could have 3, 10, 15 Cassandra containers that are all orchestrated and deployed across maybe 15 different machines, potentially even in different availability zones. So to try and take a volume and somehow magically orchestrate this into a distributed application environment, you end up with a lot of problems that ends up having the operators or the architects for the platforms, as architects that are building the PaaS, have to go in and add significant glue around and making sure how to orchestrate these into the applications. And then you run into problems exactly like Venkat was talking about, which are, now I want to take a snapshot, or I want to have a common encryption scheme across this particular application. Maybe the key used for that application is different for a completely different business unit that's deploying a different application.
That's right.
How do I provide these different keys in a cloud neutral way and don't burden my end users with making this a science project? That's really what the value of the Portworx layer is. At the core, Portworx is a software-defined storage solution. Venkat talked a little bit about CSI. CSI is going to be coming out in a couple of weeks. As soon as it's out, Portworx will have one of the first implementations of CSI out there. In fact, in a couple of weeks, we'll be announcing our release for CSI. But all of these are meant to make the integration with the container orchestrator much more easier, and to make the lives of, like Venkat and Balajee, in managing their platform as a service really hands-off, and everything is just happening on its own. They have end users, their own internal customers that they have to cater to, and in their ideal world, they're going to put together a platform where their end users can go in and programmatically say, I'm going to run my 5-node Cassandra cluster, give me a few terabytes of storage, and boom, it happens. They don't have to go in and provision it beforehand. These are the question you asked is, what are problems people running into? That's what they're running into. When somebody has to run, for example, a 5-node Cassandra cluster, somebody has to go in and figure out which machines are this going to run on, how do I get storage to it, and then invariably, those applications are then permanently pinned to those machines because they have consumed resources from it, and when a machine dies, somebody has to go in and figure out how to take it off of that, move it somewhere else, and you're really not leveraging any of the cloud native benefits that these orchestrators want to give.
Right. So how do you manage that underlying architecture with these storage considerations in mind? So, so if a node goes down, you can just take care of it.
Sure. So one of the things that we started off was to build a cloud agnostic platform so that we don't want to overburden, just like what Gu just said, we don't want to pass on the onerous task of managing infrastructure onto our end customers as well. So we've abstracted out, and there's an abstraction that we go on with every layer of Predix itself. So when we go deploy Predix on a brand new point of presence, be it Amazon or Azure, we have automation that abstracts out the underlying infrastructure first. And then we go down and lay a common interface of our platform as a service layer, which is Cloud Foundry and Mesos. At the end of the day, our end users interact with one or both, and they consume Predix no matter where Predix is deployed. Within that, we provide constructs. For example, the talk that we gave today was our open service broker implementation, which is essentially a broker marriage between Cloud Foundry and Mesos, where people living in the Cloud Foundry land can consume a backend service running on Portworx using our broker interface. That's how we are solving that problem.
So Predix is an IoT platform that actually offers folks to be able to run any language, applications on any language pretty much. So it's a microservice-based architecture. But to focus on the storage portion of this conversation, so prior to Portworx, our involvement or this thing with Portworx, so we've always run all of our persistent store using an infrastructure that's built on top of Bosch or Chef or Terraform. So these are, because Cloud Foundry doesn't natively support running these sort of pin persistent clusters, so we got to basically set this up outside of Cloud Foundry, attach it to Cloud Foundry via our service broker. With this newer model, so we're able to essentially use the the two-state scheduler from Mesos itself to sort of decentralize the scheduler portion, and also use a solution like Portworx so we can essentially go and do dynamic persistent volume provisioning. Yeah.
Excellent.
And maybe you could also mention your use of frameworks, which.
Oh yeah, absolutely. So when we started looking at Portworx and Mesos, I think one of the very important thing for us is the availability of at least some persistent stores or frameworks on Mesos to actually use that as a starting point. So we looked at Elasticsearch, we looked at the Cassandra framework, and we looked at Redis and other persistent framework, and we started working with both Mesosphere and Portworx to sort of make sure that these frameworks actually have a native support for a dynamic persistent volume. So it started as a beta, and then we've essentially made some good progress right now. So now we are at a position where we can actually go and spin these clusters. And some of the testing that we have actually done are pretty interesting in terms of mission failovers and whatnot. So if a particular container actually goes down and comes back up somewhere else, we are now able to have the ability to be able to sort of take that particular volume that's there on that old sort of failed container and attach it back to a new container. So your customers, for most part, of course there are edge cases in these things, for most part are still able to go back and look at these system as if there was no change on the infrastructure we had.
Gal, perhaps you could take us through how you guys built out your own technical architecture to be able to provide the service that you do. Can you tell us about that underlying architecture itself?
Sure, absolutely. At the core is a distributed block software-defined storage solution, right? So
Is it built in Go?
No, it's built in C, C++ actually. Performance is very key for this environment. One of the architectural tenets is look at how modern applications are built today. Just to kind of walk you through it, if you were to roll back 10 or 15 years ago, it wasn't easy to get, if you had to get 10 or 15, 20 terabytes of storage, it would almost always come off of a network. It would come off either off of a SAN or a NAS, but over the past 10, 15 years, Intel's ecosystem has made so many advances that now it's easy to go buy a server and get 10, 15 terabytes of local capacity storage, right? And you want to be able to take advantage of this. In parallel, modern applications are built like Cassandra or Mongo or HDFS, and these inherently like to scale out and handle the scale out and the aggregation themselves. What I mean is, if you take a look at Cassandra, you would want to give it the illusion of direct attached storage or this notion of hyperconvergence. Keep these two things in mind because these are important for me to describe how Portworx built out its software architecture. Our software architecture fundamentally enables people to run their applications hyperconverged. So it's more conducive for applications like Cassandra because you get that low latency access. Your applications are running close to where their storage lives. Secondly, the other thing that Portworx does is it natively integrates with the schedulers. So it knows how to talk to either DCO at Mesosphere or Kubernetes and work with the schedulers such that these applications are orchestrated in a sensible way. To give you an example of that, if you're going to deploy Cassandra cluster, you don't want all the nodes in the same ring to end up in the same availability zone or failure domain. Or for example, if it's on-prem, on the same rack. It's Portworx's architecture that lets you figure out how to distribute these applications sensibly. Also, the other thing is, typically, people are aiming for close to 80+% server utilization. What that means is we have to allow for different types of applications to co-reside on the same hardware without having IOs conflict between them. So what Portworx does to mitigate this is we don't actually directly take the drive or disk or a physical LUN and give it to an application like other products would do. We provide a virtual software storage volume, which is what the application actually talks to. This virtual volume then can implement all of the I/O leveling and making sure that people aren't stepping on each other's toes. Container granular encryption or container granular snapshots are all implemented at that level.
Interesting. So where do you guys see your platform? How do you see your platform maturing with storage technologies? And what do you want to try to accomplish over the next 6 months or 12 months?
To answer that better, so the biggest challenge that we as platform operators and platform architects, what we feel is when we provide a platform for our end users, we want to make sure that platform is highly available. That's our biggest challenge, right? That's where Portworx comes in. The way Mesos gives you a unified fabric of compute, Portworx provides a unified fabric of storage, so that we can then have end users not worry about having how to consume an HA application. That's what Portworx gives us. And going down 6 months or a year down the road, we want to be able to have this running across the world in all other point of presence as well, other cloud providers, and then on-prem definitely.
So perhaps you could tell us about the next 6 months and talk about that issue of high availability, because I know you brought this up in a story that you wrote for the New Stack about some of the drawbacks with Amazon EBS.
Yeah, I think the key thing to keep in mind here as people stateful services with containers over the past 12 months has become such a hot topic because people are now pushing these things into production at a faster than anticipated rate. The point that I wanted to make in that article is day one deployment is always easy, right? I mean, it's easy to put something together and say, here, it's working. As time goes on, your systems age. You have various things that come into practice that we've learned over the past 12 months in working with GE and others. With what happens in production, drives fail, end users are sloppy. They'll start an application and leave things up and running, and over time space gets consumed, so it's the day two operations that are difficult. And it's very important for us to emphasize as an ecosystem over the next 6 months where people can go wrong in the day two operations. And so the type of problems that we've seen people encounter are things like network partitions, or drive failures, and then having applications all of a sudden have a storm for wanting to be scheduled on a set of other servers, and now all of a sudden you're draining the storage resources from that server. So it's all of these things that you asked a question about where do I see things going in the next 6 months. It's these type of operational practices that we want to jointly, let the ecosystem and the community know of what to keep in mind, regardless of the solution that they use. Obviously, in Portworx's case, we're very cognizant of these problems. We've been learning from our own end customers in how to make the product more resilient to these type of things. And I've got to tell you, like, this ecosystem is so fantastic because when there's a real problem, customers are willing to work with you, and they'll show you the type of problems they have. So it's important to learn from that, put it into the product. And my key answer to your question is anticipating what problems can happen, and then making the product be aware of it and react to it, and allow for admins to go in and fix any kind of physical infrastructure, but not have to encounter the burden of application level uptime and high availability. It's those things that are important.
Excellent. Any last thoughts?
I think no. You sort of nailed it in the head. That I think as we move forward, I think we're going to essentially start looking at running multiple types of workloads, and people probably an application that's very, very high I/O intensive versus something that's more throughput intensive. An ability to be able to run all of this in this one cluster harmoniously is going to be the key thing for us. Yeah, and then making sure this is highly available, it's durable enough that we can actually rely for very business critical applications. Yeah.
And I think GE showcasing what they've built over here, that's key, right? Because we work with a lot of customers, and it's the same thing that they're trying to do, which is the key goal here that cloud architects like Venkat and Balajee are trying to do is, how do I get my end users that same agility that the Twitters, the Facebooks, and the Googles of the world get? How do I build a programmable self-service layer that's cloud agnostic? They can go from AWS to Microsoft to on-prem seamlessly and not impact their end users.
Right.
So that, and the more they talk about what they've done there, that also is important.
Great. Well, thank you all for taking some time to talk with us today here at MesosCon, and I look forward to keeping in touch about all your progress.
Cool. Thank you.
Thank you.
Thank you.
Thanks.
Listen to more episodes of the New Stack Makers at thenewstack.io/podcast. Please rate and review us on iTunes, like us on YouTube, and follow us on SoundCloud. Thanks for listening, and see you next time.